All right, y'all. I'm going to fill this out for you to check your answers. Number 2, we don't have enough information here, actually, as I sat down to do this. We don't know if this is regular dominance or recessive dominance. I went through and worked it both ways, and it could be either based on what we have below here. So let's just assume it's regular dominance, which would mean that all 3 of these are going to be homozygous recessive. And since this parent has nothing but recessive alleles, this child must have at least one recessive allele, and since they have the trait, they must be capital A, lowercase a. And since both of these children receive 2 recessive alleles, then both parents must have had a recessive allele, which makes the father here heterozygous. So heterozygous, homozygous recessive. Could have done something similar if you chose to do this with recessive, then that's fine. Over here, we can determine what it is, and we can determine it because of this couple right here. They're both lacking the trait. If this were dominant, they would both be heterozygous or homozygous recessive, and they would have no dominant alleles to hand down here. So this must be a recessive trait, which makes these all homozygous recessive. And if this parent is homozygous recessive, then this parent had nothing but a recessive allele to offer to these 2, and since they don't have that trait, they must be heterozygous. Same thing here. This child got a recessive allele from both parents, and this one doesn't have the trait. Remember, we're calling this a recessive trait because of this couple. And similarly, up here, this child got a recessive allele from both, and there is no trait here, so it must be heterozygous. Let's look at number 7. Number 7, we've got the same situation going on here with 2 people without the trait having a child with the trait. So this must be a recessive trait. So we're going to go ahead and fill in all of the trait-bearing people with homozygous recessive. Blech. And then we're just going to look and see, well, if this child has 2 recessive alleles, then each parent must have donated 1, and this makes this heterozygous because they don't have the trait. Same thing here. Same thing here. Now, what about this one? Let's look real quick at a cross of heterozygous by heterozygous. We could end up with homozygous dominant, we could end up with homozygous recessive, and we can end up with heterozygous. So we know that all 3 of these won't show the trait for a recessive trait. For a recessive trait, it must have both recessive alleles. So we don't know. We know that this has a dominant allele, but we don't know what the second allele is. It could be homozygous dominant, or it could be heterozygous, so we're just going to put a question mark. All right. I love this pedigree here. I kind of like this better than the other ones. So first we need to look through here and find a clue that shows us whether it's recessive or dominant. Same thing here. I guess my tip to you would be look for a place where you've got 2 non-trait bearing people having a child with the trait. If you can find that, then you know it's recessive. And sure enough, we've got that going on right here. We've got 2 people without the trait. If this were dominant, they would both be homozygous recessive and would have no dominant alleles to loan. But we can see that we've got 2 kids with the trait, so they must have had something else going on, which makes this recessive, right? So we're going to call everybody with the trait homozygous recessive. And then we'll work work backwards. We know that each parent here has a recessive allele because both of these children, and we know they don't have the trait, and it's a recessive trait, so it must be heterozygous. What else do we know? We know that these two parents, just like the cross I did on the previous example, these two parents could have homozygous dominant or heterozygous children. So we're going to have a question mark for all of those. Okay, both of these, what's going on here? Let's see here. These two created kids that had both recessive alleles, so Manny must have a recessive allele, but he doesn't have the trait, so must be heterozygous. And no way for this child to be homozygous dominant because May doesn't have a dominant allele, so this must be heterozygous. Same thing here. All of these children, there's no way to have two homozygous or two dominant alleles, so all these people with the trait, by people I mean rats, must be heterozygous. Let's see. Same thing here. Can't have two dominant alleles, so this must be heterozygous. Same thing here. Heterozygous. And I think we're done. Let me know if you have questions.